Alright, y'all. Well, I am back with what looks to be another repair video. This is something that I don't think I've shown. No, I definitely haven't shown on the channel. It's a piece of equipment I've never owned before, a piece of equipment I've never even used before, and that is a spectrum analyzer, specifically an HP 8557A analog sweep spectrum analyzer. So it has a range from 0.01 to 350 megahertz, and it's also a plug-in to this HP 182T display, which is compatible with a number of equipment types, oscilloscopes as well. Um, but yeah, I got this for fairly cheap on eBay. Um, it's not working. I was aware of that when I bought it, like most of the stuff I buy. Excuse me. Um, and yeah, pretty neat. I mean, look at this. It's got this mechanical drive for the frequency range. Pretty cool. No LED display. But yeah, and so I'm going to attempt to repair this guy. But let's go into a little bit about what spectrum analyzers are. Um, they're different from oscilloscopes in that an oscilloscope, it has amplitude in the y-axis, which is also like this, but the difference is on the x-axis, instead of time, you have frequency. Okay, so with a spectrum analyzer, you can look at a signal and look at its characteristics within that frequency range. So I'll give you an example. So with a square wave, for example, a square wave is made up of odd harmonic sine waves. Okay, so a pure sine wave would have an infinite number of these. A pure square wave would have an infinite number of these odd harmonic sine waves. And so you could look at those harmonics with a spectrum analyzer. And I kind of think of a spectrum analyzer. So my background is in chemistry, actually. That's what I got my degree in. And I kind of looked at these sort of like a spectrophotometer. So like a spectrophotometer is going to look at a sample, a chemical sample, and it's going to tell you where it absorbs at certain wavelengths. And then, so that would be on the x-axis, just like this. And then the y would be absorbance, or the amplitude, the strength of that absorbance. So it's that's kind of what it reminds me of. But yeah, that's really, I've never used one of these before, and I know they have a variety of different applications, but I can't really go into much detail there because they're very new to me. So if you're stumbling across this video because you just like to see things get repaired, and you're not sure what a spectrum analyzer is, well, we're in the same boat. Um, but yeah, so well, what right off the bat, there's a few things I can tell that are going wrong. It actually took me a while to find a trace, just messing around with it. But one thing it also has in common with an oscilloscope, at least this type of a spectrum analyzer, is you should be able to see it, the trace sweeping across the CRT, and that is not happening. So you actually have right here, you have a control. So let's take a closer look here. This control right here is your time base, and you can see right now it's set to manual. So if I adjust that, we should be able to move this trace back and forth across the display, and it's not. All right. And then auto actually will, the adjustment will be, the sweep rate will be controlled by the resolution, bandwidth resolution controls, and the frequency span per division control. So this knob here will set with the frequency span is per division. Okay, kind of like your time per division on an oscilloscope. All right. So you actually have a setting here where it says F, so that would be for the full spectrum that you'd be viewing it. And then you've got smaller divisions here, starting at 20 megahertz per division, and then it goes down to, I think, 0 or much lower, I guess 0 kilohertz. I'm not sure what that would be, but it gets lower as you turn the knob. So yeah. And then here you have your reference level. So that's basically where you're setting the trace in the y-axis. And it does respond to these adjustments, the trace. Well, it was earlier. Yeah, see, there you go. So as I adjust the reference level, you can see changes occurring to the trace in the y-axis. So there's some things working there. Okay. I actually right now have it set to, oh, I have it, it also has, kind of like an oscilloscope, a calibration point. Kind of like where you would do a probe compensation with your probe and oscilloscope. That's kind of what I think of it as, sort of. But we should be, with it plugged into the input, we should be seeing, I'm not sure what this signal is, but it does say it's 250 megahertz. But we should be seeing some type of spectrum, and clearly we're not. So again, I don't know if this is all related to the sweep, our time base not working. Could be, not sure, but yeah. So right off the bat, it looks like the 182T is working. So it could just be an issue with the plug-in, but you know, well, I guess we got to find out. Excuse me, getting over a cold. But yeah, so I think what we should do first is let's do a visual inspection. Let's do a teardown of it and see how what everything's looking like. Start there. And then I think our best plan of attack would be to make sure everything's going, we've got our correct voltages with the 182T, take some measurements there, and then once we verified that everything's okay there, then we can dive into the plugin. Yeah, so let's get started. Alright, so I've got the panels off, so we can have a closer look. And that's a pretty beefy CRT. I mean, yeah, look at that, 19 kilovolts on the connector. Yeah, there's your 3 kilovolt test point. Some large capacitors, probably for the power supply. But yeah, look at that. There's some more circuitry for the front panel controls. A lot of adjustments. Very cool. Yep. Yeah. Very cool. And then here is the spectrum analyzer plugin. Very cool. Again, a bunch of adjustment pots, trim pots, all over the place. But look at the mechanical drive. So cool. It looks like everything is working properly. I mean, that is so cool. I see, let's flip this guy over so we can get a look. Because a lot of these controls on the front, they have these wiper-based pots, but you can see some of the circular traces for where the contacts will make contact. Might have to clean those up. Again, just like the 182T, everything looks fairly clean. Yeah, no blown components or burn marks or anything like that. But just looks really neat. Really neat. I think this board here, this might be the sweep generator board. But yeah, we'll look at all that, figure out what is what, yeah. But I mean, this is just so cool. Such a neat looking piece of equipment. But yeah, like I was saying, I think first steps will be to start with this guy and make sure we have the voltages that we should, and then yeah, go from there. I think that's the best way to go. Let's start there, and yeah, we'll take it step by step. Alright, so let's check for some voltages on this this guy, and there's some test points that are accessible on this board here. So let's take a look and see what we get. So there's 4 voltages that are delivered to the plugins. You've got plus 15, plus 100, minus 100, and minus 12.6. Let's make sure we have those. Okay, so that's our plus 15. Plus 100, 100.1. Negative 12.6 at negative 12.75. And negative 100 at negative 100.1. So, all those voltages are pretty much bang on. I don't know what the specs are for those, but I would be willing to bet that they're likely within them. That doesn't necessarily mean this guy's okay. So let's see. I was looking at the service manual through the performance checks, and we should be able to feed a signal in to the external input to just make sure we get some type of, just to make sure that this thing the horizontal amplifier is working. So let's give that a try. And I can use the CG5011 for that. Before I apply a signal to this external input here, there is one thing that I think I'd like to check. And if you look at this intensity pot for the CRT, it's very scratchy, and it doesn't even seem to make it it doesn't seem to make it brighter, or it has it bouncing around the screen too. It could just be a bad pot, but I think it would be worth checking the high voltage test point at 3 kilovolts and make sure we have that. So let's do that first, and yeah, see what we get there. All right, so I'm gonna do the high voltage test using my high voltage probe. Should be getting 3 volts roughly on there, which would be equivalent to 3 kilovolts. So let's do that very carefully. Okay, we're getting about 3.2 volts, so that's equivalent to 3200 kilovolts. So that's good. Alright, so I got this board out with relative ease. This is the board that has some of the the intensity, focus, scaling pots on it, and the reason I did that was so I could clean these potentially. So I'm going to do that. I'm going to hit the intensity pot with some contact cleaner and see if that'll help bring it back to life, if that is the problem. But yeah, clearly marked where all these connections are, where they go, so I don't forget. But yeah, let's give that a try. Well, we may have another problem here. So I had cleaned up that board, put a bunch of contact cleaner on the pots, and now we have no high voltage at the 3 kilovolt test point. It was working for a second. Actually, the whole screen got a hell of a lot brighter, and I thought, okay, that's good. But the intensity pot still was doing that weird thing. Whoa, it just tried to come back. Let's power this guy off for a sec. Something strange is going on. I could literally just heard the, that electronic buzz that you hear when the CRT, you power one on, that just came on briefly and then shut off. So I don't know what's going on here. Maybe I was initially thinking a fuse, but that doesn't seem to be the case. So yeah, let me take this board out again, and well, I need to check that pot anyway, and maybe it's just a poor connection. I don't know, but yeah. Well, something is bringing down all of the supplies. So this is the negative 100 volt rail at negative 43 volts roughly. All the other ones are below 1 volt, plus or minus. But yeah, I'm not sure. I even disconnected the CRT just to see if this was something, because that's what, I don't know what else could have caused this. But yeah. So we're gonna have to figure out what's going on with that. I'd like to see if I'm gonna check the service manual, see if there's a way to isolate the supply, just to see if we can narrow this down. But yeah, yep. Can't help but think this was something I did, because all the voltages were bang on initially. And until I popped the board out to mess around with it, now it's doing this. So, yeah. Alright. Alright, so I've got the power supply module disconnected from the unit. Um, and it was actually very easy to do. In fact, the service manual states that for troubleshooting purposes to remove it. So it looks like the supply doesn't need to be attached to a load to work, which makes that easier for us. And so this meter on the left is the one that is connected to the 100 volt rail, positive 100 volt rail, which is what all the other rails are referenced to. And I've got the module hooked up to my variac isolation transformer. And you might be wondering, why do you have so many connections here? So there's actually the power supply. This is the circuit. So you've got these two primary windings at 115 volts. And so if you want to run this at 230, you would be just that switch on the back just puts these in series. All right, so but yeah, so that's why I've got two lives, two hots and two neutrals connected to it. But yeah, let's power it on and see what happens. I know this is a bit precarious, but you know. Yeah, all right. Okay. So we have our 100 volts. So the power supply doesn't appear to be the issue. I'll check the other rails as well just to make sure everything looks good, but yeah. So our issue must be somewhere else. We just have to isolate it. Okay, so that is the little connector that I think that's what I need to unplug to isolate the high voltage and CRT from the unit. Yeah. Yep. Because all the incoming voltages are on these 92, 97, 914. All those are your 27 unregulated, negative 12.6. So those are the ones, and 100 volts. Those are the ones that I need to isolate or disconnect, and that'll be possible from that connector. So it's tucked away there. Easy to miss, but yep, that's what I'm going to try. And I'm going to put this guy back. Oh, and it goes without saying, but if you're going to remove this guy, definitely discharge these capacitors. There's no bleed resistors on these. So, yeah, well, that one has one, and so does that one, but these two I don't. So, yeah. So, definitely discharge those. Okay, here's a brief rant, but you know, normally I have nothing but good things to say about HP, especially when it comes to serviceability. They usually, in my opinion, are a bit better than Tektronix when it comes to laying out their equipment and ease of access for servicing, but this is something that's a bit stupid. So you have these little clamps on both sides, right here and right there, and the power supply module will screw into these little clamps to hold this guy into place. This isn't the only spot where it screws in. There's 4 screws on the bottom too. This is how you remove it. So it's just these 2 screws and then the 4 screws on the bottom. But these clamps are like glued in to place, and it's very easy to knock them out, and then getting them back into place and screwing this in is proving to be a bit difficult and really annoying. So pretty dumb design in my opinion, that they couldn't have just found some other way to, you know, something welded perhaps to the frame. I don't know, but this is just really annoying. So something to look out for if you're taking this thing apart. All right. Now that I've got the power module back in, after that was a real pain in the ass. Those clips really suck, so hopefully if you have to do this, your clips don't become unglued, because, yeah. Anyway, the high voltage supply has been disconnected from the rest of the unit, CRT disconnected, so let's see if our voltage rails are still intact. Okay. Interesting. Hmm. Well, they're all there. Yeah. So, that's interesting. Looks like our problem might be on the high voltage board then, which sucks. Um, Not easy to troubleshoot, but yeah. All right, let's see if we can figure out a plan of attack for this. Okay, so now I just powered it, reconnected the high voltage supply, the CRT, and the voltages are there. Now I have everything turned counterclockwise so that's why it's not on, but if we adjust the scaling, okay. All right, so there's the beam. Let's All right, so I don't know. Let's bring the intensity up. But see that intensity pot. See, I did check. Um, I measured the intensity pot, the resistance of it, and it smoothly goes from 0 to 10 kilohertz. I'm sorry, 10 kilo ohms, and yeah, it seems to be fine. So this is this is kind of a bit concerning to see this happening, because it should just go from dim to bright. No, none of this weird. Um, yeah, it's just very odd. So, yeah, I don't know. Okay, so Oh man, I wish I just caught that all on camera. I just started it too late. I am currently injecting a 1 kilohertz 10 volt peak to peak square wave into the unit. That's basically what this calibrator is. All right. Um, you got your choice of either 10 volts peak to peak or 250 millivolts. And then that would, would plug into your external input. And then you'd be able to check the unit, as long as you have the external input selected for the display and not internal, which you would be using the plugins horizontal amplifier. Now there was just 2 dots on the screen, and it started in the center, and then it moved over, and then it just went right off the screen. All right, let's see if we can. I'm gonna turn it off. Oh, now it's gone for good. Oh, jeez. Oh, see, now it just went off. There, now it's gone. Wow. Yep. Unbelievable. Okay, so I have disconnected the high voltage supply cable again, and check this out. This is the plus 100 volt rail. All right. So something else is loading down the supply. It doesn't appear to be the high voltage supply. All right, horizontal amplifier board is removed. I have the unit powered on, and take a look at the voltages. There's your 100, 15, 12.6, negative 12.6, and negative 100. So, yeah, our problem might be on this board, but let's take a look at the intensity, focus, and let's just take a look at some of those controls. See if messing around with them will cause this thing to shut down like it did before. Alright, so now I've completely disconnected the CRT from the unit. It's powered on now. The high voltage supply is still connected, because removing that, when I removed the horizontal board, I forgot to reconnect the high voltage supply. And so as soon as I did that, the voltages went back down again, and they are still down. I'll show you. So that's the 100 volt, 15 minus 12.6 and minus 100. So yeah, well, the HV supply is disconnected, and I am still getting these voltages way low, and that's good, because I wasn't finding anything wrong with this board. I disconnected the multiplier and tried it. Everything, all the semiconductors on it appear to test fine. So I mean, that doesn't really leave much else. There's the gating amplifier board. Maybe there's an issue there. Let's try disconnecting that. Wow, I've pulled everything out of this unit. Everything is disconnected, with the exception of this board in the back. for all of the these inputs here, but it's still out of spec. That's the positive 100 volt rail. The negative is back, but all the other ones are down. I don't understand. Is it a problem with the power supply? I swear, if I take this thing out and it's goes back to normal, this is going to be really annoying. But that's really all that's left to do, is disconnect it again and see if it goes back to normal. You know, if that's the case, there's a whole bunch of connectors. Maybe there's two that are touching. It's got, at this point, it's got to be something stupid now, because yeah. Yeah. So as much as I hate these clips, it's time to remove the power supply module again. Let's give that a try. Okay, I have the unit out. The power supply module is out. It's hooked up to the Variac. Let's see what happens when we power it on. It's probing the 100 volt rail. Okay. Now I feel a bit vindicated. Okay. So it is the power supply after all. After all of that. Wow. This is the best outcome, honestly. Well, I was really hoping it wasn't the high voltage supply or the CRT or anything like that. So it's clearly something going wrong with the power supply, which is, again, best case scenario, I feel. Well, this is the 100 volt rail on the scope. And find it a bit suspicious that it's a roughly 0.6, 0.7 volts, you know, like a roughly what a diode, the forward voltage drop of or forward voltage drop of across a diode. I think that's possibly a clue that that's what it is. It is still so this is across the this cap right here. So I would assume this is right after rectification. Alright, so I've actually separated the so this is the A2 board. I'm sorry, A1 board, which is the low voltage rectifier board. Alright? And then, so the other board that it connects to is the A2, the low voltage regulator board. I just want to make sure that that these caps are good. We're getting no ripple on them. I don't think the problem is on this board, but just be good to verify that. So we're going to check that with the high voltage differential probe, and just going to check for ripple. The scope is currently AC coupled. Alright, we're at about 1 volt per division. So let's check each of these caps. We're going to measure across each of these caps. And just make sure we got no ripple. That'll verify that each of these caps is good, and we can move on to the next step. Alright, so this is the positive 100 volt filter cap, and that's 1 volt per division. That looks nice and smooth. Alright, this is gonna do the 27 volt unregulated supply. So this is for the high voltage supply. And that one is also good. This supply was not brought down with all the other ones, but just good to check it anyway. Next, we're going to move on to the negative 100 volt. That one is also good. And then finally the minus 12.6. And that one is also good. So I think we can rule out this board as having any of the issues. Now, it should be noted that this seems to be an intermittent issue. In fact, this is actually the following day. I haven't tried powering this thing up yet. Just the power supply module, it could be back to normal now. We're not sure. Hopefully it's not, so we can finally figure out where the problem is. But yeah, so let's go back to the A2 board and try to take some measurements. So I just wanted to share something I thought was interesting. I was just doing some measurements with on the A2 board with the unit off, just checking the transistors using the diode test function on my meter. And for Q1, which is the series regulator for the 100 volt rail, I wasn't getting any forward forward bias voltage from base to emitter. They're NPN transistors, and I was getting it for all of the other series pass transistors, so I thought maybe there was something wrong there. So I disconnected them, and Q1, and I think, well, Q1 is the 100 volt, positive 100 volt series regulator. Then there's also the negative 100 volt series regulator. Both of them are the same part number. They are an HP proprietary part number. So unfortunately, can't find much information on them. But anyway, I disconnected both of them so I could compare the two. Now, when I did remove it, I was able to get that forward bias voltage drop of roughly 0.5 volts. But check out the curves for both of them. They're very different. And so this one on the left, well, actually I forget which is which, but I'll know once I apply a collector. Oh yeah, check this out. This is the negative 100 volt transistor. I did read somewhere they have a max VCE of 200 volts DC. So I'm gonna try. Right now we're at 20 volts per division, so I'm gonna try not to go above that. But I don't even know if that's right. But anyway, so that's that one. This is the positive 100 volt one. Look at that. They're very different. But that looks good. Both, if anything, the negative 100 volt rail looks a little funky, but I think we can rule that one out as being a problem. But I just thought that was interesting to share. Well, I think I might have found the problem. So I should have had the video going when I initially fired this guy up. But anyway, I shouldn't have showed you guys my precarious cables, but this is the 9 volt temperature compensated. Sorry, my camera's not focusing. Come on. Yeah, this is the 9 volt temperature compensated Zener diode, which is the reference for the 100-volt rail, which is the reference for all the other voltage rails. And I had it on the curve tracer. It's in AC mode, so you can see the reverse bias on this side, forward on that side, and we should see 9 volts, the Zener breakdown at 9 volts. And I did. I am in the low voltage mode, which only can provide roughly a max voltage of 15 to 20 volts, and I increased it to 9 and kept going. When I got to roughly 9, we did see the Zener breakdown, but immediately after that, it just completely died. And you can see now, this is what we're getting. So it's dead now. So I think this was the problem, and it would explain the intermittent nature of the issue. I think I just killed it for good now. So yeah, I think that was the issue. This potentially, either that or I I don't see how that's possible though. Let's see, we're at 10. Yeah, I should have done a better job with. Should have turned down the max peak power watts. It's at 10. So I might have actually killed it, and maybe there was nothing wrong, but I don't know. I think this was it. It was measuring funky in circuit, which is another thing. It was like, I think it was like 1.7 volts with the diode test function. Although it could have just been, I have to measure the with it out of circuit to see if that was just the surrounding circuitry. Yeah, I think this guy was the culprit. But let me see if I have anything similar. I don't think I have a 9-volt Zener diode, but I'll check. Or something similar. Well, let me see. Let me see what I can dig up, and we'll go from there. Alright, it's all back together. The closest thing I could find was a 8.2 volt Zener, a 1N756A, 500 milliwatt. The original is listed in the service manual as a 1N938, which also is a 500 milliwatt rated Zener. But anyway, yeah. The voltage is obviously going to be off. It's not going to be 100, but let's see if this works. All of the rails are adjustable. Depending on how far off it is, we might be able to bring it back into spec. We'll see. But anyway, if it works, let's power it on and see what happens. Okay. So we're at 90 volts. Alright. I wonder if we can bring that into spec. Bingo! I was able to get it up to 100 volts. Now, it's going to require the other rails adjustments there as well. Let's see what they're at real quick. Okay. So again, we're at 100 volts for the 100 volt rail. 15 for the 15 volt. Negative 12.7 for the negative 12.6. And 102 for the 100 volt. So, awesome. Which makes sense, just adjusting the 100 would bring the other ones back, but the other ones do have their own trim pots, which is pretty cool. Okay, so every board is back into place. CRT is connected. Um, my plan was to check the supply voltages after each board was reconnected, and then I just got too excited and started connecting everything. I did do that for the high voltage board, and I did check the um, -3 kilovolt test point. We got about -3,200 volts, which is pretty much where it should be. That was without the CRT connected as well, which might explain why it's a little bit higher than it was before. But yeah, so I've got the meter connected to the 100-volt rail, positive, and let's power this guy on. I have the scale, intensity, and focus controls all the way counterclockwise to start, but let's see what happens. Okay, and I should have realized that setting those rails bang on without all the load connected, they would be a little bit lower than they should be, but 99, I'll take that for now. But let's try. There's the display. Nice and bright. Wow. And let's turn up the intensity. Uh-oh. We don't have anything. No intensity. Whoa. Shoot. But beam fine works. Ooh, you know what I just realized? It could be that yeah, it might be off the screen here. Let's try to focus. And we can do a bit better than that, right? Yeah, that's good. Okay. Nope. Interesting. There it is. So it is centered now. You can see. There it is, right there. So what am I missing? Why? Oh, it just appeared for a second. Look. Whoa. Interesting. Huh. I'm probably missing something really stupid. I feel like that's probably what's going on here. So we do have yes, the display should be internal. No. I'm sorry. Huh. Well, at least it's not failing. Okay, so I did find a problem. I did have one of these connections right here. It was loose. It was just barely touching, and so I reconnected it, and now we do have a trace, but the intensity issue still persists. I mean, this isn't, and again, it doesn't appear to be this pot. I really don't think it's this pot. Um, I did show you guys earlier that I did measure the resistance and gradually turned it up and turned it down, and it had a nice gradual increase and decrease in resistance. It didn't appear to be anything like a scratchy, or bad pot, and that is really concerning for me because that might point to a bad CRT. I but yeah. So you know, the horizontal, it does look like it's trying to do stuff. Um, I also have the CG5011. That output is on. It's connected externally, and we aren't getting anything. So no difference when the output is on or off. I'm just turning it on and off, and there's nothing. Um, Another thing, so I did attempt to measure the output at the HV multiplier, and I only got about, that was when it was disconnected, by the way, from the CRT. I only got about 7 kilovolts, and I don't know if it was because I couldn't reach all the way back there. It was kind of difficult, but I'm pretty sure I did make contact, and that was the max I was getting. It should be 19 kilovolts. I'm not very experienced when it comes to working on CRTs. I don't know if it needs to be connected to get that voltage measurement or what, but this HV multiplier is potentially suspect as well, just because of that. But yeah, it clearly looks like we solved the power supply issue, but clearly there's still something else wrong with this guy. And so gonna have to dig into that, but I'm gonna have to end it here because this video has gone on long enough. Please, if you are experienced with working with on the troubleshooting with CRTs on that side, if any of these things that I'm witnessing experience any of these symptoms, if they're ringing any bells as to, if you guys are familiar with these symptoms, if what the cause could be, please let me know in the comments. But we're going to continue working on this guy in part 2. Going to take a look at the horizontal amplifier and the gating amplifier, make sure everything looks good there. I'll look into seeing if I can get double check the high voltage supply as well, but I don't think our problem is there, with the exception of that multiplier. But yeah, so yeah, we'll leave it there. I hope you guys found that interesting. Really got to know this 182T, and tune in next time. Alright guys,